Hi guys, it's Mrs. Moss here. We've been talking about rocks and how they can be weathered and eroded. And we mentioned this before, but we're going to look into a little more detail about how rocks can be deposited once they are, after they are eroded. Now, what is deposition? Well, deposition is the opposite of erosion. Water that's slowing down can't hold the sediments that it was carrying, so it drops some of them, and that is known as deposition. You can think of the D and the D. Deposition, drop. Slower moving water on the inside of a meandering stream, on the inside of the curve, will deposit the sediments. And we spoke about that before. As those sediments are deposited, they'll build up, and create a sandbar. So this is a picture of the meandering stream, and you can see, as we mentioned in our video about erosion, water moves fastest on the outside of the curve, so it takes away that sediment at the bottom. Well, as the inside of the curve, around the inside of the curve, the water will slow down. So the inside edges of the stream that create the friction with the water will cause deposition to occur. So if you look here in this picture, you see the deposition occurring on the inside of this curve. All of this yellow is the sediment sizes that are being deposited as the water slows down around the curve. And here's just a diagram that we saw before. We're gonna look again, looking at the deposition side of the river and the side of the curve versus the erosion side. And here's just a picture of a meandering stream, but you can really see the deposition that has occurred along here where water has slowed down and dropped the sediments. Now, as we said before too, as the water moves, it will carve V-shaped valleys. But let's talk more about the evolution of a stream and how the water cuts through the land, carries sediments with it, deposits it elsewhere. So over time, the river will widen the valley and it will create a deeper valley. So this brings us to a term known as sorting. Well, sorting goes along with deposition, and it is the sediments that are left behind and how they are deposited. They can be sorted by size. If you look at this stream will first drop or deposit the larger sediments. And then as the velocity slows down, it will drop more and more sediments according to size. That's known as sorting. Specifically, we have horizontal sorting, and that's literally as a river flows into a larger body of water, like a lake, and it will then deposit the larger sediments first, the boulders and the cobbles. As the stream can continue on, even if it's moving at a slower velocity, you know that it can carry smaller particles further down. So once the speed slows down, it will drop those smaller particles. So it actually ends up being sorted horizontally by size. So the larger sediments are first deposited and then leading to the smaller once you hit the larger body of water. And here's a picture of how this can occur. You see here that there's a mountain range where a stream will come down, and you will see that it starts to curve and as the land flattens out. Well, as this land flattens out and the speed of the river will slow down, you will have depositing occur horizontally, sorting the sediments as it slows down. And here's just another picture of it. As it slows down, it will drop the boulders, the cobbles, pebbles, sand, silt, and clay will get carried a little further down and into the lake, and eventually only the smaller particles that are so fine that they're almost dissolving and they're being carried by solution. So this brings us to vertical sorting. Very similar to horizontal, except that the larger particles are going to be deposited on the bottom, and then the smaller particles will get deposited on top of those larger particles. So it creates more of like a stack vertically as opposed to horizontally. So rivers flow into oceans, as rivers enter oceans, they slow down. Sediments deposit according to their size, as we said before, except again, they will then settle on the bottom and the smaller particles will settle on top or get deposited on top. Here's the coarse at the bottom and the finer particles on top. Please make sure you draw this diagram in your notes of the vertical sorting, and if you have to go back, make sure you got the horizontal sorting picture as well. Here's a picture of, in real life, of rocks that were deposited vertically, sorted. The larger pieces are on the bottom, and then the smaller are at the top. Now this smaller particles get sorted and piled and settled on top. That's known as graded bedding, when there are multiple events of deposition occurring over a same area. So first we have one event of deposition that the water came and it slowed down and it dropped the particles or deposited the larger particles on the bottom, smaller as it went to the top on top of them. But then, as I said before, it dried out. The area dried out. And then another season came and another round of water came through the area, depositing another set of sediments. And it will sort in the same fashion. So here we have that, it's called graded bedding, where you have a series of vertical sorting events that happen one on top of the other. Creates a pattern where you have bigger particles at the bottom, then smaller particles, and then fine particles, and then you have another coarse particles, then finer particles at the top. Okay, again, another picture, a little more close up of graded bedding, which is multiple vertical sorting deposition occurring. And this is a photo in real life of what you could see. You see the larger pieces on the bottom and then finer pieces on the top, larger than fine. So what affects the rate of deposition, or how fast this will occur? Well, first we have sediment size. The larger sediments will settle faster than the smaller sediments. Therefore, the relationship between particle size and settling rate is a direct relationship. The larger the particle size, the faster the settling rate. We also have the shape that will affect the settling rate. The shape of the sediment will create more friction with the water as it falls down to the bottom. So flatter or longer pieces with a larger surface area will actually take more time to settle. So the rate will slow down. Therefore, the relationship between settling rate and shape is as it gets flatter, the settling time will increase. Now here's something that I need you to take note of. This says settling rate. What it should say is settling time, okay? If the time gets longer and increases, then the rate will decrease. The last factor that affects the settling rate of deposition is the particle's density. So if we remember back to what density is, it's the amount of particles or molecules packed inside an object, right? So which is more dense, a bowling ball or a soccer ball? Well, the bowling ball. And therefore, if we were going to drop a bowling ball or deposit a bowling ball at the same time as a soccer ball, it will drop faster. So denser particles will settle faster than less dense particles. And therefore, the relationship between density and settling rate is, as the density increases, the rate of settling will also increase. So that's all for now. We're going to talk about that's all we're going to talk about for deposition. Okay, make sure you get the relationships down, and we will see you next time. Have a good day.